Well, hello everybody. Welcome into Great Atmosphere here on this Thursday, April 4th of 2024. Uh, just wanted to get in our official Eclipse cloud cover forecasting video. My wife and I will be shipping out towards the west, starting here on early Saturday morning, and won't be back until very, very late on Monday night. So this is probably going to be the primary Eclipse cloud cover forecasting video that I'm going to put out for here on this channel. But as always, we're going to get started first by taking a look at what we're looking at across the true color CONUS imagery across the contiguous U.S. Two primary things to look at, obviously, where we have our major low pressure system, stacked low, that is sitting over pretty much Lake Erie at the moment and is spinning, creating a lot of cold air advection. You can see these gravity waves coming off of the Appalachians, and then generally widespread cloud cover across. Well, I would say that probably the big story is that this has turned into a quite significant nor'easter event. As the low kind of made its, or the surface low made its way off and into the Appalachians, another surface low formed off of the mid-Atlantic coast and has since kind of strengthened and deepened, so much so that it's creating some blizzard effects over in the northern regions of New England. A little bit of a late season, I would say beyond late season, early spring snowstorm here, and then cold air is funneling in on behind. And this is also the low that was responsible for the severe weather that we had across the Midwest and the deep South earlier in the week. And we also can see our next big troublemaker kind of spinning off. We have the primary low that is sinking south off of the California coast. And then we can also see the overspreading of the dominant upper layer flow going up and across the Intermountain West. This will definitely play a major part in our weather in the early part of next week. But other than that, not a lot to write home about in terms of weather. It's quite pleasant across the majority of the country. So let's dive into kind of what we're looking at in terms of the upper levels right now. We have our primary polar jet that is making its way in several undulations and creating that sinking low off the California coast right here in its lee. And then it's overspreading over the Intermountain West, creating quite a bit of instability, which is what we saw in the true color imagery. Then we have an area of convergence where the polar jet ultimately starts to merge with the subtropical in the south. That ultimately creates sinking air aloft, which creates high pressure and very nice cloudless skies across the southern central regions of the United States. And then, of course, we have our stacked low, and I call it stacked just because you can see that the low centers are generally right on top of one another at both levels of both the upper and lower levels of the atmosphere at the moment. We can take a look at what that low looks like. And this is also at the 850 millibar level, and you can see just how strong these winds are coming off of the Atlantic, off those warm Gulf Stream waters interacting with this cold Arctic air that is being advected up and around the Hudson Bay, back and down in here, and then interacting with the Great Lakes region. Ultimately bringing cold air, very, very cold air along the north central plains in the Midwest. But on the backside of it, we have this low that's formed off of Cape Cod that ultimately is creating quite a bit of wind problems in addition to snow for the Northeast. And we can see that highlighted by our current power outage map. Effectively, half the state of Maine is currently without power at the moment. We can kind of zoom in on Maine to see where that is, and it's particularly around the Portland region, along the main, obviously the more populated regions of the state. Quite a significant, I wouldn't say completely unexpected, but certainly is not typical for this time of year for this particular region of the U.S. And I know certainly some people were not expecting to have a nor'easter of this caliber to kind of take place this time of year. The leaves are already out in this part of the country as well, or at least they're starting to bud, which is quite interesting to see. But let's take a look at the national snowfall analysis over the past 24 hours. We saw 6 to 8 inches up and around the upstate of New York, and pretty much in the higher elevations of the borders between the Hudson and Connecticut River Valley basins. And then obviously we have our south central portions of Maine, along with lake effect off Lake Superior in the UP of Michigan, and then generalized lake effect snow circulations across the Midwest and the Alleghenies and northern Appalachians. So quite a little interesting little setup that we've had. This storm system has been a nuisance for us for the past 5, 6, 7 days. It'll be gradually shifting out to sea, thankfully. But of course, there's a lot more to talk about. So let's talk about what that looks like over the course of the next few weeks or few days with the NAN 3 kilometer. Unfortunately, you can see that the low kind of sits and stalls over the coast of Maine, but ultimately it starts to fill in and the winds start to die down a little bit, and it'll ultimately just kind of serve to keep those areas under more cold temperatures over the next few days into the early portions of the weekend. But you can see where our primary troublemaker will begin starting next week, which is what we're going to start talking about in terms of cloud cover in the lee of the Front Range of Colorado. You can see that first initial wrap up. And what's interesting about this low is that because it's not a panhandle low and it's not sinking or starting any further south, like if it were to start in if we were to dip down in like West Texas or even the panhandles of Texas and Oklahoma, we would expect it to kind of take a little bit more of a pattern trajectory like this. Not altogether dissimilar to what we saw earlier in the week last week, but instead it's kind of starting its journey here. And whenever we get these Colorado lows like that, they typically don't even make a southern lunge. They kind of appear and then they shoot off into the Great Lakes region, which is what we're going to see. And we can already see, since that main front is already kind of looking like that, that's the primary cold frontal boundary. It's already going to be reaching occlusion by the time it kind of makes it up here, which is actually good news if we are talking eclipse path, because if it were any further down south, it would be interacting with a lot more Gulf moisture and creating a more widespread cloud cover event. So we're actually kind of thankful that low started a little bit further north, according to the guidance. So let's take a look at what this looks like in terms of our 500 millibar geopotential height anomaly map. We're gonna kind of dance around here and go to different ensemble guidances just to kind of see what everyone's looking at. I parked most of them here at 18Z on Monday. This is taking a look at the Euro ensemble. We can see, and for those who don't know, we have areas that are highlighted in red as high pressure ridges, and then areas that are highlighted in blue as low pressure centers and troughs. Generally speaking, we do not want to be if we don't want cloud cover, then we want to be generally under high pressure. We want to have sinking motion above us, so that or I would say convergence aloft, so that we get sinking motion coming down to us and clouds do not form and generate over top. That is our primary thing that we want to see. So if the eclipse were going over over the Hudson Bay, well, we get pretty clear skies up there. As we get the whites, it's kind of showing obviously the boundary in between where those troughs and ridges are. A lot of disparity in terms of where those clouds are going to be. But we can see that primary low center that we talked about in terms of forming in Colorado by the time we hit Monday will kind of be sitting over the Dakotas and Minnesota. And then the major player, I would say, in terms of timing, will be where the subsequent following trough will ultimately end up, because it's taking a much deeper cut, a more far south pass. It's positively tilted, but it should be shifting into the neutral as we go forward in time. The timing of that will be critical, because if this moves ahead any further, if this is faster, that could really kind of put us through a little bit of a tailspin in terms of creating a sufficient, having a good enough window for cloud cover in terms of observing the eclipse on Monday. Generally speaking, across the GEFS, the GFS ensemble, it's not as solid, I'd say, as the Euro, but definitely we compared these two just to kind of get confidence levels. And the generalized low center and trough patterns are very similar, additionally with the ridges. So we can say with a good degree of confidence that this pattern will persist going forward into the weekend. We can take a look at how both of the flagship models have performed as of late. We have the Euro performance metric highlighted by blue, and then we had the GFS highlighted by red. You can see that the GFS took a little bit of a tumble at the beginning part of the month, only reaching the 86.5 percentile in terms of accuracy for 500 millibar anomaly correction. The Euro has generally been doing a better job all throughout the course of the year so far. So I would generally be more inclined to agree with what the Euro has to say. And generally, it's coming off with a little bit more of an agreeable pattern that has more strong. Anytime you get more distinct color variations, that also displays confidence within the model, which we do not see that same kind of level with the GEFS. I also want to take a look at the Euro AI model. This has been performing actually very, very well. It's only been in use for the past couple of months since it was announced. Since it was announced to be used for public consumption earlier in February, I believe. And you can see if we go back in time just to kind of see the transformation of what this looks like. So we see if we go back with this. So this is about right now. That's our general stacked low that we have that's currently affecting us, and we saw that obviously very well very well simulated by the satellite picture right there. And then we have ridging that's going to come out on the back side of this, and then we have our major system that's going to be making its way down and in. Now these two, it kind of has a split low kind of feature to it, where we have two low centers that'll be kind of like undulating around themselves. And that first feature is going to be the Colorado low, which will ultimately kind of wrap itself up in the Dakotas. And then on the back side of it, we're going to have the following trailing low that'll start creating problems for us into the early parts of next week. Now, ultimately, we generally, in terms of predicting severe weather, we don't like, well, if you want severe weather, southwest flow is kind of the name of the game, and that is what we are seeing across portions of pretty much the central plains and south central Texas, and into generally the deep south, although that is, you want these gradients to be closer together to kind of simulate an increase in vorticity and cyclogenesis capability. But this has the southwest flow component, which is concerning. It'll be ultimately coming down to how much moisture that this can tap into from the Gulf and the lower levels. And I think that's where the primary concern is for that portion of the country going into the eclipse day on Monday. And we can take a look at that once again, just kind of making its way forward. You can see initially that this low really is at its peak intensity on Sunday, in the middle of the night on Sunday, and then it starts to fill in because it's already occluded and it's weakening. Generally speaking, wherever the occluded front lands will ultimately be where the cloud cover will be going forward into Monday. And we'll talk about that in just a second. So one of the interesting sites that I found, Pivotal Weather, which is a site that I use quite regularly on this channel, they have put together a solar eclipse cloud watch page. I'm not entirely sure if this is available to you if you're not subscribed to Pivotal. I believe it's free for the weekend. I'm not entirely sure, so don't count me on that. It's a great site, though. You definitely should subscribe. And what they've done is essentially they have all the ensembles available to you. So we have the CMC, the GFS, and the Euro. And in addition, they have also included the NWS blend, which I know is something that is not typically something they share without a subscription. So maybe it's not something that you can see without a sub. But I do like what the blend has to offer here. But we can take a quick look at what the ensembles are looking at. I mentioned earlier, I put out this week that I put out a eclipse video, which explains everything about the upcoming eclipse, how it compares to other eclipses in the past, what the significance of this particular one is for the Americas, and along with some other great facts and figures and whatnot that I saw. And one of the things that I definitely made a point to mention is a lot of these flagship models the cloud cover metric that it has is not very well thought out. I wouldn't say not thought out, but it's a derivative of essentially a probability of precipitation forecast, and that is highlighted by by Pivotal's data team right here, saying that a lot of these metrics have to do with where it's predicting for the probability of precipitation to happen, and therefore you can't have precipitation without clouds, so that's what it uses for its cloud cover metric, which is not necessarily the most accurate way of depicting where cloud cover will be, because clouds are quite fickle. They can be either synoptically generated, which are more easy to predict, or they can be convectively generated, which are much, much, much more difficult to ultimately hone in on. So I don't really want to pay attention to anything in terms of probability of precipitation. The GFS has a cloud cover, GFS ensemble is that cloud cover one as well, and I think this is generally just useless in my opinion. If you want to use the GFS at all, I would use the probability of precip and a cloud thickness option. Cloud thickness is really interesting as well, just because the thicker the cloud, you generally would expect it to be more of a nimbostratus or like more striated layers, more thick overcast skies. And then if you have something that is more along these lines, where we're at like 26, 30, you can expect those to be more convectively generated. And thus, when we talked about in the video, is that we actually do like to have, we don't like to have them, but if we're going to choose a cloud type that we want to have overhead of us when we're hunting for eclipses, we want to have convective clouds, because ultimately they are driven by solar radiation from the surface, and those rising air parcels that come from the superheated air that's right above the ground starts rising through a cooler column of air right above it. But then when the eclipse happens, that valve of solar energy that is ultimately creating that rising motion just kind of shuts off, and those clouds dissipate quite quickly, actually, once totality and even severe partiality begins. I believe that is second contact. So cloud cover and cloud thickness is something I definitely pay attention to. But really, the NWS blend kind of does everything in terms of creating a model that takes everything into account from all the different ensembles, all the different guidances, and creates it and puts it together into one general number. So I would say in this particular region, anything below or near 30 would be a convective cloud type that I would be okay with pursuing. That is generally why, and you can actually kind of see the motions that are here. So if we have our general low that's sitting here and occluding, the occluded front, kind of that, ultimately what an occluded front is, it's kind of like the cold front has caught up to the warm front and has created pretty much just this air mass boundary. So we can say that areas up here would be cold, down here would be generally warmer or more dry, and then anywhere in the middle, wherever those air masses meet, is going to just have striated stratus clouds, overcast skies overhead. So I probably drew that where that front is wrong. I would say that the low, if it's going to be here in the Dakotas, will probably do a little bit of a thing like that. I would say the warm sector kind of injecting a little bit higher up, and then anytime that you involve the lakes, anytime you get water at all, as far as an interaction, water obviously having a higher specific heat than land, so it maintains a lot more heat than usual, and the Great Lakes are obviously not iced over, as we had kind of a winter that never was in the region. So in that particular circumstance, I would expect areas that were in these 40s and 50s. Unfortunately, areas along in that Cleveland, Erie, Buffalo, Toledo, Ohio, Dayton, it's not looking as good for a eclipse viewing experience. But on the back end of it, because this is still a low, we are expecting cold, dry air to come in and inject itself into this particular region based off of the synoptic motion that comes with counterclockwise flow or cyclonic flow. And then if we have high pressure, we knew we have a high pressure that is a high pressure center that's sitting off of the southern Gulf Coast, and that has clockwise anticyclonic flow. That is ultimately going to be the main driver for getting this moisture involved up and into the Texas and Louisiana coast, and which is going to cause a major problem for areas that are under totality in central Texas up and into Arkansas and that little piece of Oklahoma. So essentially what it does, according to what the blend is offering here, is kind of like this area right in here of northeastern Arkansas, southeastern Missouri, southern Illinois, maybe near Evansville, Indiana, and Paducah, Kentucky. This is quickly becoming ground zero for where the peak eclipse viewing is going to be if you can't be up in the Northeast. The Northeast has been the entire time pretty much cloud-free. That has been consistent throughout the course of the past week in terms of making sure that this area right around it here is pretty much in the clear, just because it has in the lee of that or trailing the major low that we're currently experiencing. The high pressure will build in behind it, creating a lot of convergent flow aloft, sinking air, and that will create some crystal clear blue skies if you happen to be in areas that are currently being inundated with snow and wind. So you get a nice reward for surviving that going forward into next weekend, I suppose. But it'll be this is kind of an interesting little dynamic here, just because in this particular region we're going to have travelers, right, that are going to be coming from all over. And let me get back to what I was looking at. So we're going to have travelers that were originally going to be maybe in the Midwest, or in Ohio and Pennsylvania and West Virginia, perhaps, and then areas in Central Texas and Oklahoma, Southern Arkansas. They're all going to be converging in on this general region, assuming that they are looking at their forecast, and not every eclipse hunter will look at their forecast. But you can safely assume that people that have taken up all the hotels and Airbnbs in the area are obviously quite invested in being able to see the eclipse. I would be quite scared to be in this particular region in terms of a traffic, in terms of a traffic possibility. But I will be part of that as well. I'm making base camp here in Louisville, Kentucky, and originally we were going to start going a little bit north to view the eclipse, probably east of Indianapolis. But seeing this, we're probably going to take more of a westerly trip over and into the Evansville, Indiana region, into maybe Champaign, Illinois, or something like that. Maybe down into Paducah as well. So that's just kind of how flexible you got to be, and you got to maintain mobility going forward. So let's take a look at the differentiation between both convective and synoptic cloud types here. And this is showing our 500 millibar geopotential height and cyclonic vorticity map. Essentially, what vorticity is kind of the energy ribbons that you need to create to create frontogenesis on a synoptic level. So without these deep colors of red and orange and yellow, generally red and orange is what we want to see, you're not going to be able to form anything on a frontal boundary basis. And the frontal boundary clouds are what we do not want to see, because those are the clouds that don't rely on solar radiation inherently, and thus whenever the solar radiation gets cut off by the eclipse, the clouds actually stay where they are instead of dissipating like a convective cloud would. So in this particular circumstance, we have this as a 21Z, which is about mid-afternoon on Monday, and we can see the majority. We can see that low sitting off and into the Dakotas and western Minnesota, and then we have our trough extension, which is kind of going like this. You can see kind of that little bulge right there that simulates where the occluded front will be, and that's why we are seeing that kind of this generalized line of vorticity extending out and in, back and into where the low center is, and not down here in the Ohio and Mississippi River valleys, or the Missouri River valleys. And then this is with the Euro model at 500 millibars. This is the general trailing low that'll be digging. Actually takes very more positively tilt here in this deterministic model. And it won't be as much of a concern, I would say, in terms of creating synoptically generated cloud cover, with the exception of down here in southeastern Texas. And we can see what this looks like as well in the relative humidity metrics here. This is taking a slice of relative humidity on a percentage basis from the 700 to 300 hectopascal or millibar levels of the atmosphere, along with mid-level winds. And you can see where our mean surface level pressure centers are. We have our high pressure center sitting off the Carolina coast, and our low pressure in the Minnesotas and Dakotas. Now, an interesting other component that I definitely want to highlight is what the effect of wind shear will be on generating clouds as well, and even a severe threat going into the later portions of Monday. You can see that by these wind barbs right here, that we have pretty strong winds extending all the way from West Texas, going all the way down and into the Carolinas. And but you can also tell that based off of where the surface pressure centers are, at the surface, the winds are going to be kind of doing something like this, right? And you can tell that the winds are not necessarily, especially as we get up and into the Gulf and into Texas, like this. And you can tell that just by going parallel to the isobars here. They are not going in the same direction, and that is that is the definition of wind shear. We have a change in direction. We have a change in wind speed and direction with height, and that will ultimately create a atmosphere that is conducive for creating spin in the lower portions of the atmosphere, and probably because there is no synoptic generator here, no frontal boundary, with the exception of maybe like a dry line that'll exist in the lower levels. This will be all convective. This will be all a convectively generated mode. So possibility for some discrete supercells to be along this region as well, as they kind of implode on themselves if they have adequate moisture. The issue with so we have the adequate moisture obviously by virtue of being right next to the Gulf Coast. We have a low-level jet that'll be screaming in by virtue of that high-pressure system, but we also are going to have generalized dry air injections all the way in and out throughout the Eclipse path near the Ohio, Mississippi, and Missouri River Valley deltas, and in those particular regions that we looked at before. So that is generally, I would say, a good thing, because any cloud cover that does kind of form here will be convective in nature, and thus should the solar radiation valve get shut off, that ultimately means that the clouds will kind of dissipate on that of themselves, which would be, I think, is a good thing, and that kind of reaffirms my the hunch that this is going to be the main area to want to be if you can't be in the far northeast for the eclipse in the United States. So let's take a look at what else we have. We can also take a look at what those mean surface level pressure centers look like in terms of temperatures and heights. We can see that the low itself, you can see how deep it gets, 984 low, as it comes off of the Colorado, off the front range of Colorado, and then it starts at 984, and then it starts to weaken as it occludes, and it's already, by the time you get to 18Z Monday, it's already at 1005. It's effectively filled in completely, and the high pressure starts to dominate and bring in some more generalized air, generalized warm and moist air on the back end of it. But I think because of this drier, colder air that's coming in from the Canadian prairie on the back end of this low feature, that'll ultimately stymie a lot of that generalized warm and moist flow coming off of the Gulf. And the intersection between those two will probably be more further south, which is why they're expecting for that particular forecast to be. So let's take a look at what the atmosphere will look like in terms of the upper levels of the atmosphere at the time of totality. We can see that we have that generalized upper level low sitting over the Minnesotas and Dakotas, and then areas of diffluence aloft. That is kind of an indicator that we are going to be seeing cloud cover in these particular regions as well, and you can see that extends often into anywhere that this kind of turns into from red to green. That's where we'd expect to see that frontal boundary to kind of be at the throughout the course of the atmosphere. So that is where I would expect the cloud cover, the stratus clouds to kind of begin, overcast skies, and then generally speaking on this end, upper levels is a little bit trickier to kind of see. We can take this down to it's more of because it's the convective mode. It's a convective mode that creates discrete supercells in this circumstance. We would expect to have most of the cloud cover to be convectively generated, and ultimately, the longer that the area sits in the warm and moist sector, the higher chance it has to developing severe weather on the course as the course of the afternoon wears on. Now, an interesting little component to whether that severe weather actually comes true is actually the eclipse itself. Does it temporarily stymie the amount of solar radiation so much so that the severe threat is nullified for the late afternoon for this region? It's not entirely out of the question. I would be very interested, and if I was a PhD candidate, I might be very interested in making that happen in terms of seeing if because this is the exact type of severe event possibility that would be thwarted by an eclipse, just because without that solar radiation heating coming off of the planetary boundary layer, you're not getting the necessary rising motion in the atmosphere. And then if the rising motion obviously goes through an atmosphere that is highly sheared, that's where your spin happens for your storms. But if there's no radiation to begin with, does it just completely nullify the day for storm mode? So it'll be interesting to see for sure. But that is generally what we're going to be expecting at the surface levels. By that sense, we have our high pressure sitting off the southeast coast, low pressure sitting off and into the Dakotas and Minnesota, and then that ultimate area right in here where we're seeing that kind of diffluence is where we're going to expect to see more cloud cover across the northern portions of the Midwest, up until you get into the far northern reaches of New England, and that's effectively looking at that's effectively it in that sense. And we can take a look at what we're expecting from the two flagship deterministic models. And generally speaking, obviously we're going to be looking at the Euro in terms of determining our best bet, and it's definitely showing more of a precipitative mode. But these are more scattered, and where it's green, that kind of simulates that convective nature to it. There isn't a clear boundary of any kind that's showing on this deterministic operational model. And then GFS is generally speaking on board. Might have the low a little bit further off and into the southeast, opposed to the Euro. Thankfully, I don't think that is the case. I'm thankful that the Euro is being a little bit more accurate, because we want that low to be as high up into the north as possible, so we can get even more cold and dry air to inject its way into our area of highest confidence to have no clouds, or very little clouds, or at least convective clouds in that regions, and that's a good thing to watch. And also, just want to end on what the National Weather Service has, or the Weather Prediction Center out of Silver Spring, Maryland, has put out here. This is currently their forecast as of today on April 4th of this morning. The percent of cloud cover, percent of the sky covered by clouds at 2 Eastern, which would be around the time of the eclipse totality. And we have anywhere that is in that 30 to 40% range is generally what I would consider to be more of a convective mode, especially considering the synoptic features that are not necessarily available at this particular juncture according to the guidance. But we can definitely see where that warm and moist air intersects with the cold and dry air that's being advected in from the Canadian prairie by virtue of that filling in low in the Dakotas and Minnesota. That ultimately will be the boundary of which there will be some convective initiation starting to form along the southern reaches of the eclipse totality path. And then we can see where that included front ultimately lands will ultimately dictate where the cloud cover striations will ultimately be in the portions of Ohio and Erie, Mississippi, or Erie, Pennsylvania, excuse me, and the Adirondack region of New York. So yeah, it definitely does look like this is the area right here. I'll be there. It should be a lot of fun. I'm expecting quite a bit of traffic, and I hope you'll be able to get back. Hopefully you'll be able to get back before midnight or 1 a.m. on Monday, traveling back to Charlotte. But I'm excited. I do encourage you folks to obviously, if you can't make it from wherever you are, to definitely get the eclipse classes anyway. The entirety of the solar eclipse. Let me get real quick to this handy dandy eclipse map. So here's our total solar eclipse. Get the eclipse shadow path. This is what it's ultimately going to look like. Anywhere that you are in the yellow, essentially, you'll be able to see at least a partial solar eclipse. You'll definitely still need to be able to see, be able to have the eclipse glasses available to you, just because you're going to need. Let's see. This is really good. This is timeanddate.com. They have a really well done eclipse path map, so you can see, like, oh, I'm in Atlanta, Georgia. What is the eclipse going to look like to me at its highest point? Well, it's going to look like this. So it's still going to is it going to darken the sky at all? Maybe a little. You can see that little change in color there. And then obviously the closer you get to the path of totality, let's look at Nashville, right? So 95% will be covered in terms of the eclipse, and you can see just how dark it gets. So you can see the sun and the moon getting just covered right there, and that's kind of like the peak for Nashville. So you can see it definitely does get quite dark before it starts to move out and away again. But then what does it look like in terms of in the path itself? Let's look at Indianapolis Indianapolis, probably one of the largest centers for the eclipse itself. And you can see it starts perfectly sunny sky, and then we go into darkness. Right? And that's incredible stuff. And that eclipse will last almost 4 minutes, which is crazy. 2017 eclipse only lasted usually about 2 minutes max in most areas of the U.S. that could see it. This doubles the amount of time that will be in totality. It's going to be just an incredible event. Spare no expense to be able to see it. It's not the next total solar eclipse that crosses America will not be until 2045. So, 21 years before it is ever going to happen again across the American subcontinent. So, certainly a lot of fun to be had. A lot of research and science to kind of dive in on, and ultimately just a rare and cool event. It's awesome to have kind of this celestial shadow dance make its way across our own neck of the woods. You know, it's usually quite difficult to be able to see one of these things, and to have it cross your own country is quite the privilege. Quite the privilege for sure, especially considering the astronomical odds that go into making an eclipse like this happen. But that's all I got for y'all today. I do appreciate you tuning in to Great Atmosphere. Be sure to subscribe for more weather forecasting videos, whether they be astronomical in sense or not. I'll have another video out for you when I get back next week, maybe with some pictures of the event itself, if I can get that all uploaded and ready. But definitely take a look at the eclipse video that I put out earlier this week on Monday. And other than that, I wish you all safe travels and have a great rest of your day. Take care.